it should be. I mean, I could see that. Like this is kind of like basically Hunger Games meets golf.
Random people in the audience get guns, and that's wow. They just get to.
Yeah, but I mean that would be kind of boring. What you'd have to do is you'd have to have like these mad scientists like create these like weird hybrids and just release them onto the course.
Drums and tasers.
You know, this guy's like standing over a 4-foot putt, and all of a sudden something just comes out of the water hazard. You've seen that?
It really is a water hazard.
Right.
I think that's.
Have you seen that? There's a commercial. I think this is an insurance commercial, something about, golf announcers whisper, that's what they do or something like that. And these guys, and all of a sudden a kraken comes out of the water hazard and grabs the guy. It's like, he's definitely going to lose a stroke in this hole. This course is electric. People are running for their lives. That's the way it should be. Yeah. And that's coming from a golf fan. So, I mean, I would support that. Because then, it's never over. Some guy comes to the final hole with a 3-shot lead. You figure it's over.
He just gets eaten by the kraken.
Yeah, the guy cannot complete his round. He bogeyed 10 too, back-to-back bogeys. He gets disqualified for not signing his scorecard. He was eaten by a kraken. Although there's been some pretty funny things historically. There's this guy, Van de Velde, his last name is a French guy. It was the British Open in maybe 2004 or 5 or something like that. And this guy had a 3-shot lead coming into the last hole. And if you're this guy's caddy, you basically snap every one of his clubs in half except the putter. You just say, play in. This dude takes driver off the tee, although basically almost gets into the water hazard, lucked out there. Then he shanks his neck. He got lost. Fell apart last hole. He was like wading in the water hazard, trying to hit a ball that was underwater. Yeah, that caddy should have been fired.
I think the caddy should have been fired. I think the dude messing up those shots is the one who.
Oh, at that point, when your player is 3 up with 1 hole to lead, it's the caddy's job to not let your player make stupid decisions.
So he should have started off with, hey, don't put it in that water hazard over there?
No, he starts off by throwing half of his clubs away. Here's a pitching wedge. You're using this club for this hole.
I'm just saying, if the caddy is the one who should know this, I think the professional golfer should also know he shouldn't.
Well, the guy was overconfident because he had been playing well.
So he deserved it.
Well,
All I'm hearing is it is the golfer's fault.
Caddy gets 10%. The caddy had a vested interest.
Caddy gets 10% then. He takes 10% of the blame for that one.
Yeah, well, the caddy had a vested interest in this guy not screwing up. I don't know.
See, bet on the other dude.
The whole bag's just filled with drivers. It's like, do you really need anything else? All right.
Get it right the first time.
Let's see here. All right, so our issue at the end of last class, we had our server listening, and I think we can telnet to our server, right? Is this restarting, rebuffering? There we go. Something. It's very strange how that. Let's just kill that one. New terminal. And we're 3,000 again. Yeah. Yeah, so we're telnetting to our server. Our server is successfully writing something over the socket. So it's our client that currently isn't. I think we have a segmentation fault in our client right now, don't we?
I think we had decided that that wasn't needed anyways. All right, but segmentation fault when it runs. Okay. So let's walk through the client and see where we're being dumb here. And just quickly, do we take that? We made our server a pointer up there. We did the same thing here. All right, so port 3000, there's our socket address server. The reply we'll receive is up to 2000 bytes, 127.0.0.1 inet. Here's the port. Well, we'll leave that for now. I don't think that's necessary. Here's us creating our stream socket. That should work fine. Here's us creating our, so let's look at the connect here. Because we're checking on the server on the bind, right? Yeah, so let's just, we'll copy that error message here and go after server FD, server FD. Problem with connecting, else we are connected. And we print out the port. All right, so just for the sake of argument right now, let's comment this out and make sure that we're successfully connecting. So let's get the server running again. Recompile the client. Rerun the client. Is it that mem set? Server. What is it crashing on? That should be fine. That should be fine. That should be fine. Here's our socket. Here's our server size. We're never actually using that though, so I can get rid of that. So we're connecting to sockfd, the struct sock address server, size of struct sock address. So it has to be dying on this line. Let's just prove that real quick. That's got to be, the connect has to be where the segmentation fault is. Ooh. That's interesting. Oh, here, let's just make sure it's not something completely dumb. We'll comment everything except a variable declaration. Okay, good. Something in our code. See, this is where a nice debugger would come in handy. All right, I think we should be able to get to there without trouble. Should be able to get to there without trouble. And we can't. Okay, so it's in one of these 3 lines, and I suspect it's in that very first one. Yep. All right, so this is the line that we have a problem with. This is the line on our server side. Let's paste it underneath. Oh, that's interesting. All right, I have type socket net inet. Oh, do we not have net inet over it? No, we have it. Standard list, standard IO, string H. Okay. Sock address in. Server. Oh, actually, just out of curiosity, let me do these lines first. Let's see if the problem's with the struct. It is. Okay. And really, the first part of our client is identical to our server. What are we doing differently? All those guys should be the same. I think all we have is string.h added to this, yeah.
My guess would be that they don't like you using multiples.
Well, I'm the server side compiles and runs. And that guy's doing his initial setup identically. Although our server does not technically return a 0. I'm going to throw the laptop if that is it, because it returns an int. There should be no reason. Okay, good. Dodges the bullet. It was going right at Chastity too.
I got somebody in my line of sight.
What's up?
Yeah,
Look at Arc.
The arc.
All right, so why does this guy give us a segmentation fault, but this guy does not? it's not doing anything. Struct sock address in pointer server. In pointer server. It has nothing to do with localhost because it will crash if I put these out of order. I mean, we're just setting values in this struct. So if I do that, it crashes on that line.
So wait, then why, if you're just setting a value there, why does setting a value cause a segmentation fault?
Well, segmentation fault's usually something with memory. So that's indicating that creating this guy up here is not actually giving us a struct. Like this should give us a, oh,
Is it because you're doing the pointer?
well, it shouldn't be because I'm doing a pointer in here. Server is working. Here is our pointer. We don't do anything with it till we get here, and then we're dereferencing it. I don't think so. I mean, in the client, we can, if we take away the pointer there, and then we change these guys to dots so we don't get to use the cool kid arrow. This should be identical to what we just had. Therefore, we should still get a segmentation fault. And we don't.
Computers are awesome.
So why am I allowed to? This will be an interesting experiment. So I'm going to take, this is what we currently have in client. We're going to go over to server. I'm going to comment out everything in server. We're going to paste client in there. All right, we compare. That goes back to server here. Compile. What the heck? Are you serious? I compile it, it runs fine on the server window. We'll take the client, which is the identical. I copied it. We copied that, right? Oh, hold on. We're I did. We're back to the address version of this. So with our server, we'll do it this way. All right. So here's our server code using the pointer. Compile it. Okay, that guy gets a segmentation fault now as well. Okay. So there's the server using the pointer. So if I comment the server to here, and I save it, we recompile and run. Okay, we get a segmentation fault then. in. So which line actually generates the segmentation fault? I think we proved in the client that that won't be the problem. So that should run fine. But if we move it down one line, now we do have the problem. All right, there's our segmentation fault. But in the server, if I just haphazardly decide that everything is just going to roll, now it listens. All right, so if I comment the server here, the server works without this comment in here. If I add this comment all the way to the bottom, it crashes right here.
Is it because the struct isn't completely filled?
Well, it's got to start somewhere. I mean, you have to have your first line of filling it. So there's our segmentation fault as it is right here. But if I uncomment the entire rest of this program, changing nothing above where it's currently having a segmentation fault, it works. I guess let's keep just chasing the thing down here. Okay. We'll take bigger steps. Okay, I mean, we know that the whole thing works. So how far down do we have to go before it decides that it works now? Okay. How is that possible? Ay, that doesn't make any sense. How could all of this code work? But that didn't. Is that right?
Did you go to the client though?
This is all on the server right now.
With that last
So
part?
I literally have everything running except filling message with hello and sending some stuff.
Well, that part didn't work because there was no.
But the thing is, this segmentation faults. But if I come and just say I'm going to let everything run, it works now.
That doesn't make sense.
Does it run if you comment out after filling message with hello?
I don't think it will. But that doesn't, even if it did, that doesn't explain why it crashes with just that line. That runs. And message was defined up here. So was it a segmentation fault because I didn't use it?
if you, what if you delete message for right now? Comment out both the.
Well, we can delete it from here. Well, here,
Yeah, comment
along the lines you're going with, and let's go this route. We know this will run. And we have a similar, slightly different thing over on the client side. And that is, let's get our client back to where it was originally. So I'm guessing it's this server reply thing. If we take server reply, and right now we're not even using it, so we'll just leave it alone. Oh, I still have a comment in here. It's our port, socket address. I'm going to just put server reply down in here for right now. You see on this one, if I comment out that, well here, let's comment out the rest of it because I never gave message a value. Actually, this could be an interesting compiler thing because this would be a 2-pass compiler. I think this should give us a segmentation fault. Okay. But if we take out this initial pointer and never fill that with a value, compile, run. Oh, we still get a, well, that makes this page not make sense anymore. With that variable defined, and us giving it a value and nothing more. This does not give us a segmentation fault. But if I move this comment from here to here, never giving message a value, this now has a segmentation fault, which typically is a memory pointer problem.
Well, then wouldn't that be the same thing as the server?
We're on the server right now.
Yeah.
I would say forget about the client for a second. Why is it that if I have the comment start here, the only difference is I'm putting a value into this variable. Why is it that it's okay? It's a segmentation fault right now. Now it's not.
Well, I mean that makes sense because when you did the pointers into the server sign family.
This is only this one variable here.
I know, but when we had the same issue with the struct,
Mm-hmm.
that we weren't completely filling the struct.
No.
So was that why we were getting the segmentation error?
No, we were getting the segmentation error because we were never filling char pointer message.
Or was it
It's
both?
the same issue. I think that if you fill message with hello right below where
No,
Where
because
you-
it was going through that fine. It was the first time that we tried to do something with it. That
So when you put that
gave the segmentation fault.
That's not even true either.
It isn't?
No, we never actually did anything with it. I mean, I still had it all commented out here. We never sent it or anything.
But wasn't it? You had everything uncommented. You had everything commented out, and then when you did the first, like where you assigned the local host INET address, when we did that, that's when it crashed. But before that, it was working fine. When you had that, basically what you have on the screen,
Yeah, here.
commented out, it was working.
This will be interesting. Let's do that. And let's do that. Is this a segmentation fault? Okay. Which means that this would not be a segmentation fault either. Okay. But this is a segmentation fault. But this isn't a segmentation fault. Okay, so this is the false positive. So if we do this, we don't get a segmentation fault. So is this us overwriting memory? See, technically here, we're never actually asking for memory for this, this message. So char pointer message becomes a little dangerous there. Do 20 times size of char, like that. And then we'll comment that out again. What the heck? We know that that is fine. And we know we fail right here. So it's got to be that char. All right, so we fail there, but we would not fail here. This will work. Okay. All right, so since we didn't specifically reserve memory for either of these things, they're both sharing the address space allocated to this process.
You can specifically tell it what memory to use with C, can't you?
That's what you would do. What I just a second ago I put that malloc in there, so we could do this. We could do malloc. Let's let's see, this would be size of sock address underscore in. This is a struct. So this says, give me enough memory to hold that thing.
Is it sock address or is it just socket ADDR?
Sock ADDR. Oh, ADR, yeah, thank you. So we're saying allocate some memory. How much? This much. This message thing should be inconsequential. This should, let's just make sure it doesn't crash on just that. Okay, we're good there. Now let's see if we can write something to this right away. Okay, so that fixed it. So was this just random luck that when we how could that even be though? How could it work without allocating memory for it? I mean, really, the only answer is we were lucky. It just so happened that this char pointer and our server space, so if I go like that and comment out the rest, there's nothing that says that this should work. If I can't get to line 20 otherwise, if I comment everything from 21 on right now, this crashes. But with everything uncommented, it runs. And it'll still run now, but now we've specifically requested memory. Which means on the client side, we can do the same thing. Steal our so this guy should now be happy again. We could still do this mem set thing, even though I don't think it's necessary. Yeah. That's infuriating. Strangely appropriate for a systems programming class. Because since we're using command line tools and we're not, we've chosen not to use a debugger, we're not able to walk memory and see the issue. This is similar to race conditions, where it's difficult to recreate a race condition, but race conditions are found. In this particular case, we had memory available that we didn't own that we still use, and it just so happened, this is at least my prediction, that we filled up the correct amount of memory by the end of the program. And since it's a two-pass compiler, it goes through once and collects symbols, it goes through another time to fill things in, to actually process those symbols. By having everything uncommented, we reserved enough total memory to fulfill what this guy needed over here on the server as soon as we let, because I think we saw that if we did it, thank you, Siri. I think we saw that if we commented everything from this point down but left the message equals hello, that's what fixed it. This arbitrarily is requesting memory. Message equals hello. So that's C's underlying C string library that's saying, oh, okay, you've given me a string literal. I'm going to go ahead and
create memory and make message point to it. Well, it created that memory inside of the memory space that was assigned to this process. Well, that just so happened to be that the next pass through, when it actually started assigning things, how is that a runtime? This is a run. This would not be a compile time. So it would be a runtime. What does it? Oh, that's even more interesting. This isn't from a two-pass compiler. This has to do with the nature of the low-level language, the assembly code that the compiler is outputting, where it's likely setting up your variables and their initial values. So since message is not used until down here, it's probably front-loading memory allocation. So it's rearranged things. Remember when we talk about compilers, we say one of its jobs is to try to make a bad programmer look better. So by the time we actually give value to message at the assembly level, we've gathered enough local memory to be able to do this. So message must get a value prior to that. So we lucked out because the compiler produced assembly language that allocated memory in the right order for us. It's interesting and infuriating at the same time. But punchline is, and this is a good punchline, in C, because this predates automatic garbage collection, we are always responsible for creating our memory and actually deallocating our memory. So when we're done with this struct, technically it's our job to also deallocate that address. So it should be and dealloc. I think that's it. This probably shows us the alternative. Free. It's called free. So a good C programming citizen would say after we have finished connecting to our sock address stuff, after that's all done, then we can go ahead and free server, giving the memory back to the operating system. We're responsible for doing that in the C programming language. Realistically, we would probably put all of our deallocation stuff maybe down here at the bottom. So anytime we allocate memory, just free it at the bottom. So now we're being a good citizen. So this gives us memory. Here's filling in our stuff. That's fine. This memset thing's probably not really needed, but we're doing it anyways. Here's our initial socket. Here's our server connection to that socket. If everything was cool, we say we are connected with the address. Now we're going to go ahead and get a reply from the server. So I'm actually going to do a char pointer here. We're going to continue to be good citizens. And server reply is going to equal malloc 2000 times size of char. Technically, putting the array thing with the 2000 in it should do this, but at this point I don't trust anything. This would be very much the old school way of doing it. This is defining a 200 bucket character array. By specifically, this is what the new keyword does in Java. When I say it's our real estate agent and goes and requests some amount of memory equal enough to fill this many of the type, we're asking for enough memory for 2,000 of these guys, whatever the size of char is, which in this is going to be a one byte. All right, so now we should get, we'll pass in that address into our server reply, get how many bytes were for blah, blah, blah. So that should be our receive.
Okay, so now we should be able to get our actual incoming connection, I believe. That looks legit. We've requested memory. This looks legit. We've requested memory. Technically, we didn't request memory down here. So we probably should have just done that should work. Just go with it. This makes me a little nervous since technically we're not specifically creating memory. We're relying on C strings, which is the first iteration of strings in C. Before that, everything was a char pointer. Basically, think of it as instead of having strings, you just everything is character arrays. So now we can create our server. It's listening. Let's make sure the client is saved. Compile the client. Connect. Oh, receive still failed, but we did connect. I wonder if we have to pass it the address of server reply. Oh no, it is an address already. All right. Well, once again, no homework. It looks pretty likely you're going to have homework on Monday.
I think I heard that.
Yeah, but it actually looks likely this time. It actually looks likely this time. What's Jordan's?